So far we've been looking at pedigree diagrams where we actually know the pattern of inheritance. All the conditions we've been looking at have been recessive conditions. But just sometimes as a geneticist you'll be presented with a case, maybe a novel condition, where you don't actually know at the outset whether a condition is dominant or recessive.
In this pedigree diagram, you can see that two parents who lack a particular condition have given rise to two children who also lack the condition, and also two children who have the condition. The key tells us that the shaded boxes represent those with the phenotype of the condition. What you're not told is whether the condition is dominant or recessive. When you're presented with a pedigree diagram like this, if you reach a situation like this, the fact that the parents at the top have given rise to children of both types tells you that the type representing the condition is actually the recessive type. Both parents must therefore be carrying an allele for the recessive condition. Finally, we're going to look at the problem of sex-linked conditions. You'll probably remember that in humans there are 23 pairs of chromosomes, and you have 22 sets of what are called autosomal chromosomes, and on the bottom right of this picture you've got the two sex chromosomes. So for human females it's XX, and for males it's XY. Let's look at a condition called Hunter's disease, a very rare condition but a very unpleasant one. Because the gene that can give rise to Hunter's disease is carried on the X chromosome, we can look at the pattern of inheritance. Let's start by looking at females. One possibility is that both of the X chromosomes for a particular female have got the normal or unaffected version of the gene. So they've got the big A allele. Another possibility is that there'll be a carrier. On one X chromosome they'll have the big A allele. On the other chromosome they'll have the small a allele, which is the disease gene, or the disease allele. The third possibility is that the woman will have the disease allele on both X chromosomes, and she will therefore be a sufferer. If we compare that to males, you can see that with males the alternatives are fewer, and that's because males only have one X chromosome. Always remember the condition is not carried on the Y chromosome. There are some conditions which are carried on the Y chromosome, but we're not going to consider them in this videocast. So the possibilities for a male are that they have got the normal version of the gene, the normal allele, meaning they will be X big A Y, or they are a sufferer, in which case they will have the X small a Y genotype. So if we now look at, we can see here that we've got two unaffected parents, and they have had three children, one of whom is affected. Now when you're presented with X-linked recessive conditions, one good thing to remember is that the options for males are very much fewer, and therefore you can go straight to the males on the pedigree diagram and unfailingly identify their genotype. With females you can't. They could be carriers, but males can't be carriers because they've only got one X chromosome. And so down at the bottom of the screen here you can see the alternatives for males, and we've got one affected male. The other thing to bear in mind is that boys always inherit their Y chromosome from their father. Therefore, boys always inherit their X chromosome from their mother. So let's look at the two boys in the second generation of this family. We can see that we've got second from the left an affected son, and on the right hand side an unaffected son. So in other words, X small a y second from the left, X big A Y on the right hand side. We know that the father is unaffected, therefore he must be X big A Y. And we also know that both boys must have inherited their Y chromosome from their father. So therefore they must have inherited their X chromosome from mum, and mum is unaffected, so we know that she must have at least one X big A. However, the presence of the affected child tells us that she's also carrying the X small a. So as with all genetics problems, when you're starting to solve a pedigree diagram, go for the certainties first of all. And in this particular case, the certainties for an X-linked chromosome are the males. You can always identify the genotype of the males with an X-linked recessive condition.